All right, we are looking at different graphs of polynomial functions and sort of describing what we can see about a polynomial just based on the behavior of the graph, okay? So first of all, some things that are in your notes. It says if both arrows go up or down, or both arrows go the same direction, then the polynomial that is graphed would be a polynomial that has an even degree to it, okay? So for instance, these both go up. The ends of these, and there's not arrows because our software that we use to make them doesn't put the arrows on them. But that is a parabola, of course. You know that parabolas have a degree of 2. And both endpoints go the same direction. And so that would be an even function. And of course, a degree 2 has an even function. Okay? The red one, the end behavior here goes like that and like that. So do you see how the end arrows go opposite directions? So that means it's a polynomial that has a degree that is odd. In this case, this is a cubic graph, and cubic, of course, it has a degree of 3, and 3 is an odd number. Okay, so that's kind of what that looks like. To figure out the number of real roots, you look at how many times it crosses the x-axis. So this one crosses the x-axis here and here, so it has 2 real roots. This one crosses the x-axis here, here, and here. So it would have 3 real roots, okay? And then we'll look at how we describe their end behavior in a minute. All right, so here we go. This is a polynomial function. Of course, the arrows go the same direction, and because the arrows end up going the same direction, it is an even degree. I want you to know that this is a quadratic equation that has a degree of 2 because it's a parabola, just so that you kind of recognize that. I didn't ask you that in this question, but I'm just going to keep bringing that up. To define the end behavior, okay, first of all, you need to know this. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So if you need that, that might help you. So describe the end behavior, okay? So first of all, I'm going to label my 2 ends. The ends are the arrows, where the arrows are. I'm going to call this end 1. You can call it whatever you want. It doesn't really matter. But you can see that it is definitely in quadrant 3 down there. So I'm down here in quadrant 3, okay? And basically what you're going to do is you're going to do what it says right here. That's really all you have to say. And I will read that for you so that you can kind of say that. So end 1 goes like this. As x approaches negative infinity, basically what that means is as your x value is getting smaller, so as I move down this line, and you know the line would eventually go on forever and ever and ever, and it would get wider like this. So as your x value is getting smaller, your y value, or your f of x, is also getting smaller because it's going down and down and down and down and down. So as x gets smaller, your y value, or your f of x, also, whoops, that's a horrible infinity sign, gets smaller, okay? So just so you know that that's what happens. As x gets smaller, f of x gets smaller, okay? Now I'm going to describe part 2, which is this end arrow right there, okay? Now this is a little tricky because it looks like it's in quadrant 3 down there, but you need to know that this line is going to get wider and wider and wider as it goes, and it actually ends over here in quadrant 4 because it'll eventually cross the y-axis. Okay, so it does actually end in quadrant 4, and in quadrant 4 I'm going to use this. Okay, as my x's get bigger because I'm moving to the right, basically you're moving to the right and down. So what that means is your x's get bigger. As your x's get bigger, your y's will get smaller. Because you're moving to the right, so your x's get bigger, and you're moving down, so your y's, or your f of x's, are getting smaller. Okay? How many real zeros are there? You want to look at how many spots it crosses the x-axis in, which is 2, and so it has 2 real zeros. Okay? We'll do a couple of these. Here's another one. Okay, again, I'm going to label this as 1 right here, and this as 2, just so that we know which end we're talking about. Okay, first of all, my arrows go opposite directions here. I have a down arrow and an up arrow for my ending, so I know that this must be an odd degree, and of course you know that this is a cubic equation. That's what cubic equations look like. Cubic equations have degree 3, which of course is an odd number. Okay, so to define the end behavior here, of course what's happening right here is I move this way, I'm moving to the left and down. And so because I'm moving to the left and down, my x's are getting smaller, and so are my y's. Okay, and up here on part 2 up here, I am moving to the right and up. So if I move to the right, my x's are getting bigger, and I'm moving up, so my y's, or my f of x's, are also getting bigger. We're approaching positive infinity, okay? Or you can use these and these as kind of a little cheat for you, okay? All right, here is a linear equation. It's a line. Of course, lines have degree 1. And we know that that's an odd number. So clearly my arrows go the opposite direction, odd number, and I am going to label this as 1, and this is 2, okay? By the way, on this last one, I forgot to answer how many real zeros there were. It crosses the x-axis in 1, 2, 3 spots, so there are 3 real zeros. All right, over here, the end behavior, okay? So I'm starting with part 1 right here. Notice what's happening. I'm going to use this because I'm in quadrant 2 up here. And so what's happening here is if I'm moving along that arrow, I am moving to the left, so my x's are getting smaller, and I'm moving up, so my y's, or my f of x's, are getting bigger. Okay? So for part 1, as x gets smaller, your y, or your f of x, gets bigger. Okay? Down here in part 2, I'm moving to the right and down. So when I'm moving to the right, my x's are getting bigger, or approaching positive infinity, and my y's, or my f of x's, are going down, so they're getting smaller and approaching negative infinity. How many real zeros are there? There's 1, because it crosses the x-axis in 1 spot. All right, and lastly, is this even or odd? This function, your graph, is, you have arrows going both the same direction, and so this is an even function. Define the end behavior. So here we go. We have 1 and we have 2. Okay? So here's what I'm going to use for 1, and here's what I'm going to use for 2. Again, if you don't understand that notation, if I follow this arrow, I'm moving to the left and I'm moving up. Okay? So if I'm moving to the left, then my x's are getting smaller. And if I'm moving to the up, my y's, or my f of x's, are getting bigger. Okay? And for part 2, you're moving to the right and up. So if I'm moving to the right, my x is approaching positive infinity. And if I'm moving up, my y's are also approaching positive infinity. How many real zeros are there? This graph does not cross the x-axis in any spot at all, so there are no real zeros here, which is entirely possible. Okay, that should do it for this time. Okay, I lied. Sorry, I have this last little problem I have to do. If I'm asking you to find f of x minus f of a over x minus a, okay, a little tricky, but f of x I already have. It's right here. So that's 3x minus 3. Okay? F of a means I want you to put a in here, and I want you to subtract that whole quantity. So I want to subtract 3a minus 3. And again, you have to remember to subtract that whole quantity. And then I have x minus a over here. Okay? So if I subtract this whole quantity, that means I distribute the whole thing through, and I have 3x minus 3 minus 3a, and then a negative times a negative becomes plus 3. Okay, if I combine my like terms on the top, that and that cancels each other out, and then I have this. And you might not be able to picture this on the top, but what you can do is you can factor a 3 out of here, and if I factor a 3 out of there, then I have x minus a on the top. And then, of course, my x minus a's cancel, and I get 3. Okay? So, now I'm done.